Alright, the only thing on this one that's slightly different is I see a trig expression here and a trig, or I guess term, also over here, but one of them is squared. And remember how I had mentioned we want to isolate, if possible, the trig term. I cannot isolate it because I cannot combine them. You may have to, on some of these, actually use your 5.1 skills where you simplify them to convert them to a single term. But instead, what I'm going to do is I'm going to move it over so that I can recognize that it is a quadratic type equation involving trig. So I have 2 cosine squared of x plus cosine of x minus 1 is equal to 0. So I have actually 3 terms, this term, and this term. But like I did on the other previous problem, I'm going to let u equal to cosine of x. And the reason I'm doing this is so that you can see that it's going to become a quadratic equation. So it's going to be 2u squared plus u minus 1 equals to 0. And this is a quadratic equation that we've done before. How do I solve this? We could use quadratic formula, but I'm going to see if it's factorable. So I'm going to multiply the last term times the first term. So what's negative 2? Give me the factors of negative 2. 1 and negative 2. 2 and negative 1. And I want which factors add up to the middle term. 2 and negative 1. So I'm going to split this middle term into positive 2u minus 1u. And just continue writing your problem. Here I still have 2u squared minus 1 equals to 0. What do these two have in common? The first two, and then what do these two have in common? So on the first two, what do they have in common? And one of the u's. So I have u plus 1 inside. What do these two have in common now? Negative 1. So factor out the negative 1 and you're left with u plus 1. This middle term splitting should result in now two terms, all of this and all of this. Kind of extended that, but it's all of this only. And they both share that u plus 1. So I'm going to factor out the u plus 1, and I'll be left with 2u minus 1. Okay, so just the middle term splitting factoring. And once we have this, we can set each factor equal to 0 and solve for u. So u is equal to negative 1. If I move this over, it becomes positive 1. Then divide by 2, I get 1 half. All right. Now we move on to this side. Running out of space here. Are we solving for u or are we solving for x? So I'm going to move over here and say now these two right here. U was what? What did we let u be? Cosine of x. So cosine of x is equivalent to negative 1, and cosine of x is equivalent to 1 half. Now if I set this over 1, cosine in terms of SOHCAHTOA is adjacent over hypotenuse. What's going to happen here? Can I have a right triangle where the hypotenuse is 1, but also the adjacent not be 1? No right triangle for this one. And again, you can make a note, hypotenuse must be greater, or must be greater than adjacent. It should actually be the biggest side. So you cannot have an adjacent be the same as a hypotenuse. The hypotenuse be the same as the adjacent. Alright, so how do we solve it then? So instead, we're going to use the parent function graph for cosine of x. where does cosine start off at? 0 or 1? At 1. Remember, it does this. I'll do a better graph. Now, you should be familiar with this parent function. The period is 2 pi, so this is 2 pi. Halfway marker is pi units. And then this is a halfway marker between 0 and pi. So this is pi over 2. What is this one over here? Okay, don't forget that's 3 pi over 2. Let me zoom in on this one. We want to know when is cosine of x equal to negative 1. So if we move to our graph, cosine of x is 1 here, 0 here, and we can see at negative 1, it's at pi units. So at this location is where cosine of x is equivalent to negative 1. So here my solution is going to be x is equal to pi. Plus what? Well, what is that something? 2 pi. Alright, so we're done with this half. What's left to do is now we have this other half over here. We have cosine of x equals to 1 half. Can I do a right triangle for this one? Yeah, because if you look at this, the hypotenuse is 2. That's okay. Well, so long as the adjacent is not 2, but it's in this case it's 1, so right triangle will work here. And for this one, we're going to go ahead and do what we've done before, sketch the locations for x, because remember this inside or the input is an angle. Excuse me. So this is x. X would be here. X would be here. So x, reference angle for x here, reference angle for x, and reference angle for x. Right triangle for each scenario. Adjacent should be a 1. Hypotenuse a 2. In all of the scenarios. This one has to be negative, so I'm going to eliminate these quadrants already. And again, I can put on here cosine of x is negative 1 over 2, not positive, which is what the problem requires. And we've done this already. This is square root of 3, square root of 3 negative, so this is 60, this is 60. Starting from here to this terminal side, that is 60 degrees. And starting from here, rotate to this other terminal side is 300 degrees. And of course, if we want to convert this to radians, this is pi over 3. This is 5 pi over 3 because 60 times 5 gives me 300, so 5 times this pi over 3 would be my radian measure. All right, the last thing, of course, would be to now say my answer on this side is going to be pi over 3 plus 2 pi n, and x is also equal to 5 pi over 3 plus 2 pi n. We do have to indicate somewhere on here that n is any integer. It's actually all these answers right here. All right, now you kind of saw how, I started off with this problem right here. Cosine of x equals 1 half, and we ended up with this scenario right here. In fact, on lesson from 4.4, I would just give you this problem. We actually only started off with first sketching angles. Then we started moving on to 4.4, where I would give you something like this, where I would say cosine of x is 1 half, then you would do this problem. On the last exam, I kind of, time was an issue. And it wasn't so much to kind of pressure you to, you know, try to do it as quick as possible, but because you're seeing how these problems kind of stack up on each other. First, we started with just doing this in 4.4, and now you see that in 5.1, it is just but one component of the much larger problem. And in fact, this kind of problem kind of infuses what we did in college algebra, where we're looking at quadratic equations, solving them, and then we move on to the trig over here on solving. So make sure that you kind of keep practicing on this because time could also be a factor in when you do the exam. Any questions?